WISE, again, is the Wide Field Infrared Survey Explorer, whose mission was to map the complete universe in infrared light. Wide field means the opposite of your pocket camera, where you zoom into something. Wide field's the opposite. Zoom out and you see a lot of the sky in a single picture. Infrared, and you'll see many examples. In addition to the Tycho supernova, you'll see many examples of why we want to look in the infrared. It's a survey. That means that we're not, unlike a Hubble, for example, we're not going up and pointing at certain objects to look at particular objects. We're surveying the whole sky in a systematic pattern. And it's a NASA Explorer class mission, which of course makes a great acronym for the program as well. In the process of doing this all-sky survey, we expected to find hundreds of thousands of asteroids, many that had never been seen before, for the simple reason that asteroids happen to be much brighter, emit much more light in infrared than in visible. Here's another example of the difference of what you see in visible and infrared, an example that is maybe closer to home. This is a picture of our principal investigator by the name of Ned Wright down at UCLA. You can see the typical visible picture, but look how dramatically different the infrared picture is. The features that come out and the features that are dark are completely different, which is why you can see things in infrared that you can't see by looking in visible. This is a cross-section of the WISE instrument. You can see right here is our little telescope, 16 inches in diameter. Down here are our detectors, or our focal planes, or cameras, whatever word you'd like, are down here at the bottom of the telescope. The light comes in through the top, bounces through 13 mirrors, and comes down to the cameras. Now remember, we have to keep it cold. So the easiest way to keep it cold is just the same thing you do with a drink. You put it in a thermos bottle. And this big assembly is essentially a giant thermos bottle. I really am quite proud of the fact that little old Utah State University in northern Utah has built an instrument that will have an impact on the astrophysics community worldwide, not only today, but for decades to come.